So the rest of chapter 3 is going to get to play with something called matrices. Matrices is the plural form for the word matrix. No, we're not going to be studying the movie or anything. So a matrix is just a way to organize data. By the way, some definitions here. Rows are going to be the number of horizontal things that it has. Columns is going to be the up and down. And we define matrices based on these dimensions. Usually it is row by column. So this one, I'm over here on these examples here, it has 1, 2 rows, 1, 2 columns. This one has 1, 2, 3 rows, 1, 2 columns. Okay, this one's a 3 by 1. This one's a 1 by 4. The one back up here was a 2 by 5. So, again, we just kind of organize this. If it says to organize the data in a matrix, literally what I'm just doing is, oops, come on, pen, there we go. 6.6, 6.8, 5.9, 3.2, 2.2, and 1.1 and 1.4. I didn't quite leave myself enough room. Usually you should wait to draw your brackets until after you write all the data, but so the cool thing is then you can add, subtract, do different things to the rows and columns. Yeah. So we can add and subtract matrices together as long as they have the same dimension. That is the key that we have to follow. They must have same dimension. And then basically you just add the stuff that's in the same spot or subtract it, whatever it is. So like on 2A, -3 and -4. You see how like they're both in the first row, first column? Those are the ones you can add together, assuming they're the same dimension. Let's double check. This is a 1, 2. Whoops. 1. Why isn't it working? 1. Oh. 1, 2. 1, 2. So it's a 2 by 2. 1, 2. 1, 2. This one's a 2 by 2. They have the exact same dimension. Awesome. Add them. So -3 and -4. See how they're in the exact same spot? I'm going to have to write my answer to 2A down here, I think. So -3 minus a -4 is a double negative, which makes it -3 plus 4, which is 1. Now I can do the 4 and the 12. 4 minus 12, do not forget the negatives or the minus sign there, is -8. -9 minus 8 is -17. And -5 minus a -7 is a double negative. -5 plus 7 is 2. Draw your brackets. Boom. Done. Awesome. Let's try 2C. This one is a 1, 2, 3. 3 by 2. This one is a 1, 2. 1, 2, 3, 4. This one is a 2 by 4. Do they have the same dimension? No, they are different. Therefore, you cannot add these ones. So I'm just going to write not possible. Okay, then we're going to do some scalar multiplication. Notice we are not going to multiply two matrices together yet. We're going to do that tomorrow. The rules are very weird for that. Today, we're just going to do what we call scalar multiplication, which first of all, the way we're going to typically see this written is like that, but it's going to tell you that T is an entire matrix. So I'm just going to rewrite that really quick. Actually, I'm just going to sneak the, -4 right here. Check this out. -4 times this whole matrix. And literally all you're going to do, I want you to think distribute. Take -4 times 8, what do you get? Take -4 times 0, what do you get? -4 times 3. -4 times -2. Okay, now do the bottom row. -4 times -1. -4 times -4. -4 times -2. -4 times 9. That is your answer. Oh, what the heck? There we go. That is your answer, that thing right there. So the complicated part of today is that they're going to give you something like this right here. Just means you got to do multiple steps at once. And it's just like simplifying an expression. You just follow gems. So -6, 12. Come on. I don't know why this pen's giving me such trouble. 12, 5, 5, -4, 4, -7, plus 7, -5, 3, 6, -8, 2, 9. Okay, I just substituted B and A. And now simplify. If I had given you, 2 times 3 plus 7 times 4, you would say, oh yeah, I just need to multiply those first, then I can add them together. Well, that's the exact same thing. I just need you to multiply these first, then add them together. Okay, what is that? -72, -30, -30, +24, -24. Tell you what, that was the bell. I think you guys probably got a pretty good handle on this. What you're just going to do then is go ahead and distribute the 7. Double check that they have the same dimensions, which in this case they should. Add your 2 matrices together, and that'll be your final answer. All right, there you go.